Today, on how it's made. Replica clay pipes. Drinking fountains. Orange liqueur. And compound bows. Clay tobacco pipes may have been the first disposable product. For centuries, smokers in North America and Europe used them until they broke, which happened often. Clay pipes fell out of widespread use at the end of the 19th century, but they're still made today by clay artists with a reverence for history. Nostalgia is the new niche market for clay pipes. Popular at historical reenactments and coveted by collectors because history buffs like an authentic puff. At this Midwest American studio, the craftsman starts with a small wad of clay. He rolls it long and thin and flares the shape at the end. This establishes the basic shape of a Native American-style clay pipe. He drives a taper stick into it to hollow the long stem and stops just short of the flared end. He rolls it with the stick inside as he continues to shape the clay. He trims the flared end and now transforms it into the pipe bowl. He presses a handmade stone tool into it to make it hollow and then flares the bowl some more. To better define the shape of the bowl, he kneads the clay from the outside. He removes the stone implement. He now works the pipe bowl entirely by hand to make the thickness of the wall a little more uniform. One more roll, and then he punctures the bowl cavity to link it to the air passage. He bends the bowl upward, and then sculpts the clay a little more. He sets it aside to dry a bit. The clay hardens, but is still soft enough to carve into with the edge of a wood tool. To create notches and other trim marks, he gently presses the tool into the bowl. He tweaks the shape a little more and leaves the pipe to dry much longer now. The moisture evaporates and the clay solidifies. Using another stone tool, he grinds off bumps and other surface flaws. The grinding leaves little scratches on the pipe. He rubs those away with water. The clay quickly absorbs the small amounts of water, and the surface of the pipe dries in a very short time. After that, this replica native pipe looks pretty smooth. Other native pipes are more elaborate. The bowls are decorated with effigies of an animal or human. Here, the artist sculpts a man's face onto the bowl. He uses a blunt stick to raise a couple of eyebrows and add nostrils. He rolls eyeballs and plants some ears on the side. The pipe bowl will serve as the mouth. Native people believe that smoke carries their prayers to the gods. To make an English tavern pipe, he shapes the clay in a mold with a metal wire inside to create an air channel. He trims the excess clay. He stamps the maker's mark onto the base of the pipe. After he removes the wire used to make the air channel, there's drying time, and then he fires it in a kiln at approximately 1100 degrees Celsius. After 17 hours, each pipe is a solid piece of white ceramic. He fires the native pipes outside in the open air. He builds a fire around them using bark, leaves, and twigs. This is the traditional way natives have hardened their ceramic items. As the fire burns, the clay hardens and takes on a smoky black finish. The fire dies down, and he removes the now hardened clay pipes. Still hot, he removes them with tongs and sets them aside to cool. Later, in the studio, he dampens a cloth with mineral oil and rubs it into the clay. This seals it and gives the sooty finish a nice patina. It takes the craftsman about 3 days to make one of these replica clay pipes. They're sure to provide a whiff of nostalgia. There's nothing quite as thirst-quenching as a sip at a water fountain after playing in the park. The modern drinking fountain was invented in the early 1900s as a result of health and sanitation concerns. Today, it's a safe source of water. It waits to serve no matter what the weather, and at the touch of a button, you can drink your fill of refreshing water. Essentially unchanged for decades, it is the ever-dependable drinking fountain. A worker begins by coating the concrete molds with a release agent. The molds are made of fiberglass and metal. He makes sure the coating is thorough so that the molds will be easier to pull apart later on. With a cloth, he also coats the rubberized cap of the mold. The cap will eventually become the top of the fountain. After he applies the coating, the worker assembles the inset portion of the mold. He then puts the fountain frame, made of galvanized steel rods, into place. He assembles the two sides of the mold, with the fountain frame enclosed within. Using nuts and bolts, he ensures the mold is nice and tight to avoid seam lines in the concrete. He now inverts the assembled mold on top of the cap, again making sure all the pieces of the mold are as snug as possible. Using wooden spacers, the worker makes sure the frame inside is precisely centered. He slips in the core of the mold, which will create the void needed for mounting hardware. This wooden cover will keep the concrete out. A mixing machine prepares the concrete aggregate mix. A computer controls the portions of sand, rocks, pebbles, and water used in this recipe. Once the employee is satisfied with the consistency of the mixture, he directs it into a wheelbarrow. As the worker pours concrete into the mold, the mixture oozes evenly into the available space. He completely fills it in a matter of minutes. He uses a trowel to smooth the edges. 2 to 3 hours later, workers carefully pull the core from the mold. Once the cement has cured overnight, workers lift the top of the mold off and peel away its cap, revealing the top of a brand new drinking fountain. With a rubber mallet, the worker separates the sides of the mold from the concrete fountain. The fountain pedestal is still a little rough around the edges, so he gives it a high-pressure water wash. The spray gradually removes the superficial layer of concrete, revealing the textured concrete aggregate mix underneath. The concrete aggregate becomes a sturdy material with sand, rocks, and pebbles, not just on its surface, but all the way through. The aggregate mix is durable, with no rust or peeling paint. It's aesthetically versatile and comes in a variety of colors. A worker now assembles the plumbing. He places 2 washers on this lead-free brass fitting and applies a thread sealant. He holds the bubbler in place on the stainless steel bowl and attaches a fitting underneath. He applies more thread sealant to the elbow fitting and, after putting it in place, makes sure it's carefully aligned. He then inserts a stainless steel drain, followed by a washer and nut to hold it in place. He attaches a mounting bracket to hold the bowl assembly to the frame inside the concrete fountain. A worker now fits the bowl assembly into the top of the fountain pedestal. The mounting bracket holds firmly to ridges in the concrete frame. A worker attaches the button assembly, which holds both the button and the valve controlling water flow. He attaches the elbow fitting to polypropylene tubing and attaches the button plate to the fountain pedestal. A slot in the pedestal prevents the bubbler from being twisted or turned. All that's needed now is a thirsty customer. Tradition dictates that orange liqueur be served as a digestif, but nowadays it's also used as an ingredient in popular cocktails. For instance, mixed with tequila to make a margarita, with gin to make a white lady, or with vodka to make a cosmopolitan. Orange liqueur is also known as triple sec, triple referring to the fact it's distilled 3 times. Sec is French for dry. However, this liqueur isn't dry at all. It's actually very sweet, even though it's made with mostly bitter oranges. Triple sec was invented in 1834 by this distillery in France. The liqueur is made from a combination of sweet orange rinds and bitter orange rinds, which are green, imported from Haiti. The rinds arrive sun-dried, so the first step is to rehydrate them by soaking in cold water for about 12 hours. The next step is running each and every rind through a revolving razor to remove the white lining. Left on, this lining would make the liqueur taste bitter. Rind with its lining removed is referred to as zest. While the distillery will divulge that its liqueur recipe calls for significantly more bitter orange zest than sweet orange zest, the precise ratio is top secret. The next step is what's known as maceration. They soak the zest in sugar beet alcohol for about 5 days, during which time the rinds soften and the alcohol turns slightly orange. At the end of the maceration phase, they pump the alcohol and transfer the zest into a long-necked copper vessel called a still. Once all the alcohol and zest are inside, they close up the still. Then they release hot steam, which heats the still, bringing the alcohol to a boil. The alcohol evaporates, rising up the still's long neck until it reaches a condensation system, which cools it to liquid form again, but now with a more concentrated flavor. This entire distillation cycle takes about a half hour. The result is a spirit of bitter and sweet oranges that has an alcohol level of between 86 and 88%. The first flow out of the still, called head phlegm, is white due to the orange oil which has risen to the top. Once that oil flows off, the spirit is clear and ready for another distillation the next day, then another the day after. 3 distillations in all. The final spirit, called heart, now has an alcohol level of 81 to 83%. They pour a precise amount into a stainless steel mixing vat. In a different mixer, they combine water and sugar, heating until the ingredients concentrate into syrup. Then they add the syrup to the spirit, the proportions are top secret, and mix for at least an hour. The syrup gives the liqueur additional sweetness and dilutes the 80% alcohol level in half to 40%. In the distillery's quality control laboratory, technicians test samples regularly to ensure that the liqueur's alcohol level is always consistent. On the bottling line, the first station is a rinsing machine. It disinfects the interior of the frosted glass bottles with alcohol. Next, the bottles proceed to the filling station. These are 750 milliliter bottles. However, the liqueur is bottled in several different sizes. The next station places a metallic twist cap onto the neck of each filled bottle, then twists it until the bottle is tightly sealed. The final station simultaneously applies front and back adhesive labels. Triple Sec is a completely colorless liqueur, not what some might expect, given its unmistakably orange flavor. The bow and arrow have come a long way since the Stone Age. In the 1960s, an American engineer added cams and cables to produce what is now known as the compound bow. Concept-wise, he hit the bullseye. With this new bow, archery entered a whole new era. The compound bow puts greater energy behind the arrow so it flies faster and straighter. This means it's more likely to hit the mark. It starts with this computerized tool. It carves a lattice work of holes in the riser, which is the aluminum framework. The holes lighten the bow substantially. Next, a printing cylinder applies an activator to release inked graphics from a starch-based film. The film rolls into a tub of water. The film dissolves and the camouflage-style graphics are now afloat. Machinery dips the bow risers into the floating artwork and the graphics adhere to them. A camouflage design now covers the entire surface, including all the crevices. After a wash and dry, the risers are sprayed with a clear acrylic coating. In the meantime, a technician prepares 10 bowstrings at once. Each string will be made of 20 synthetic strands. He ties the fibers to the prongs of a wheel, and as it turns, it winds the 20 fibers into one bundle. The result is a bowstring that's so strong, it won't stretch under tension. Next, the string builder wraps one of the bowstrings around the posts of a jig. He winds a thin braided string around a strategic section to reinforce it. This is called serving. He closes the jig to loop the string at the reinforced juncture. This loop will be used to tightly attach the string to the pulley wheel known as the cam. He loops the other end now and spins the synthetic string wrap further to provide extra protection. He stops at the point where the arrow will sit prior to shooting. He pulls the string apart and inserts the end of more serving string. He winds it around this site to bolster the bowstring at this location. He burns off the end to seal it. He ties a loop around the reinforced section. This is known as the shooter's loop. It will be used to nock or hold the arrow. To keep the string from oscillating when drawn and ensure a quiet, steady shot, they install 2 rubber dampeners. A machine pulls both ends of the string through the dampeners to slide them into position. The riser is now finished, so they add the handle, string stop for more dampening, and the arrow rest. It's time to give the compound bow that all-important leverage. He screws a limb and cam to each end of the riser. A device presses the bow to load tension. He slips the end loop around the cam post and winds the string around the cam track. He pulls the string to the other cam and winds it. He then turns the cams to tighten the string. Finally, he runs 2 cables to the cams, completing the mechanics of the compound bow. He splits the bowstring at a predetermined location and inserts an aperture through which the archer can view the target. He now frees the bow from the press and locates the shooter's loop more precisely with a special measuring stick. Satisfied with the placement, he tightens the loop to the string. He winds more synthetic string around the aperture to secure it. He burns the end of the string down to the knot to prevent unraveling. At this factory, they produce 1 compound bow every 3 minutes. With production targets now met, it's time to aim for success at the shooting range.